Okay, so question 1a. A girl rides a bicycle that is powered by an electric motor. A battery transfers energy to the electric motor. The EMF of the battery is 16 volts and it can deliver a charge of 43 kilocoulomb when discharging completely from a full charge. The maximum speed of the girl on the horizontal road is 7.0 meter per second. With energy from the battery alone, the maximum distance the girl can travel under these conditions is 20 kilometers. Surely the time taken for the battery to discharge is about 3 into 10 to the power 3 seconds. So we have been given the speed and the distance, and we have to find the time. Therefore we will use the speed is equal to distance formula. So we will first rearrange the formula for t. So t is equal to distance over time, and the distance given is 20 kilometers, so we need to convert that to meters. Therefore we will multiply with 1000. So we'll have 20,000. So 20,000 over 7.0 will give you 2.85 into 10 to the power 3, and that is equal to 3 into 10 to the power 3 when you round it off, and that's what they want here. But for part 2, deduce the average power output of the battery is about 240 volts. So we need to know two equations for this question. So the first equation is that the voltage is equal to work done over the charge, and the second equation is power is equal to energy transferred by over time. So first thing, so over here we know what the voltage is. We have 16 volts. We know what the charge is 43 kilocoulombs, so we will have to convert that to we have to remove the kilo from there, so we're gonna have to multiply that with 1000. So 43,000 coulombs. So now that we have this, P is power equals to energy over time taken. We can be also written as power is equal to work done over time taken, that is shown over here. And we know that work done over here is equal to the voltage into the charge. So we have the voltage 16 volts and we have 43,000 coulomb. So now the formula we have is the voltage into the charge divided by the time, and we're just replacing this W over here with the voltage into charge. So 16 into 43,000 divided by 2.85 into 10 to the power 3, and that is equal to 241, and when you round that off you'll have 240 watts. That's how you solve part 2. To solve part 3, friction and air resistance act on the bicycle and the girl when they move. Assume that all the energy is transferred from the battery to the electric motor. Determine the average resistive force that acts on the bicycle and the girl. So the resistive force is actually equal to the force of the engine. Therefore the equation we're going to use now is power is equal to force into the velocity. So we're going to rearrange the formula for force as they're asking us for the resistive force. So when you rearrange the formula, we're going to have F, the force is equal to power over the speed. So we have 241 watts, which you got in the previous question, and you would divide that by 7.0, which is the horizontal speed traveled by the girl, and you will receive 34 newtons, and that will be the answer for part 3. So B, the bicycle and the girl have a total mass of 66 kg. The girl rides up a slope that is at an angle of 3.0 to the horizontal distance, calculate the component weight of the bicycle and the girl acting down on the slope. So to calculate the component, you will have to use the formula mg sine theta. So basically we have the mass 66 kg. We know that g is equal to 9.881, and you'll multiply that into sine 3.0, so that's the angle given here. So when you multiply mg sine theta, you will get 33.8, and when you round it off you'll have 34 newtons, and that's how you solve question 9. And as for question 2, the battery continues to give an output power of 240 volts. Assume that the resistive force are the same as in question A3. Calculate the maximum speed of the bicycle and the curl up the slope. So to solve this question, the sum of the backwards force is going to be equal to the resistive force plus the force of mg. So we already know the resistive force, and that is 34 from the previous question, from question A3. And then we just, as we got just now, 34 newtons for F mg. So that will be, when you add the two values up, you'll have 68 newtons. Then we will have to use the formula. Power is equal to force into velocity, and that you can find the equation in the data booklet over here. So you'll have to rearrange the formula for velocity as they ask for the speed in the question. So when you rearrange the formula, you will have power over the force. So the power is equal to 240 watts, which we got from the previous questions. And as for the force, we just got the answer, 68 newtons. So when you divide 2, you will get 3.5 meter per second, and that's how you solve part 2. As for part 3, on another journey up the slope, the girl carries an additional mass. Explain whether carrying this mass will change the maximum distance that the bicycle can travel along the slope. So for this, so the first thing is that the maximum distance will decrease because more energy is being transferred to the gravitational potential energy of the girl. So these are 2 points you need to write for this answer. So for D, the bicycle has a meter that displays the current and the terminal potential difference. For the battery, when the motor is running, the diagram shows the meter reading at one instant. The EMF of the cell is 16 volts. So determine the internal resistance of the battery. So to solve this question, lost volts is going to be equal to epsilon minus the voltage, and that's divided by the current. So in the question here, the epsilon is equal to 16. So 16 minus of 12, which you've given here, divided by 6.5, which is also given here, and that will give you 0.62 ohms, and that's how you solve D. As for E, the battery is made from an arrangement of 10 identical cells as shown. Calculate the EMF of one cell. So each connection here, it can be considered as 5 into x, and that is equal to 16. Because the EMF of the cell is 16, therefore x will be equal to 16 over 5, as there are 5 cells are shown. So that will be equal to 3.2 volts, and that's the answer you'll get for part 1 of E. As for part 2, the internal resistance of one cell. So to calculate the internal resistance of one cell. So in the previous question, we saw that each connection can be considered as 5 into x divided by 16. So the resistance for each parallel connection, it can be considered as x over 2. So therefore, you will multiply 5 into x over 2, which will give you 2.5x. And when you divide that by 0.62, when you will rearrange the formula for x, 0.62 over 2.5, that will be equal to 0.25, and that is how you solve part 2.